Something's wrong with 3i Atlas, 7.2% trajectory deviation. That shouldn't be possible. In October 2025, the European Space Agency's Mars-Orbiter confirmed what astronomers feared might be true. This interstellar visitor wasn't following the rules. The trajectory shift wasn't a measurement error or a calibration mistake. It was real. And the implications are staggering. Stop. Think about that for a second. We're not talking about a minor adjustment or a small computational error. This is an object moving through space in a way that our most sophisticated models say shouldn't happen. The EDS data didn't just confirm a new trajectory. It revealed that something fundamental about our understanding of orbital mechanics might be incomplete, and that's the problem we need to solve right now. The scientists at the Minor Planet Center updated their designation on November 12, 2025. They had to. The original calculations were now useless. 3i Atlas had done something that no other tracked object had done before. It changed course without any visible force acting upon it. No collision, no fragmentation, no obvious outgassing. Just a sudden, unexplained shift that has left the astronomical community scrambling for answers. Here's what makes this urgent. If we can't explain why 3i Atlas changed trajectory, we can't predict where it's going next. And with its closest approach to Earth scheduled for December 5, 2025, at just 0.37 AU, we have less than 3 weeks to figure out what's happening. The object is currently visible in Ophiuchus, requiring at least a 20-inch telescope for observation. But even with the best equipment, we're seeing something that doesn't make sense. Dr. Avi Loeb's team detected the deviation first, 7.2%. That number kept appearing in their calculations. It wasn't going away. When multiple independent observatories confirmed the same result, the reality became undeniable. This wasn't human error. The object itself was behaving anomalously. The Hubble Space Telescope's October 2025 observations gave us our best size estimate, between 180 and 220 meters across. That's roughly the length of 2 football fields, small enough to have escaped detection until recently, but large enough that its gravitational interactions should be predictable. They're not. At perihelion on October 29, 2025, 3i Atlas reached a velocity of 68 kilometers per second relative to the Sun. That's not a typo. 68 kilometers per second at just 0.23 AU from our star. For context, that's faster than any natural object should be moving at that distance without additional acceleration. The Sun's gravity alone can't account for this speed. Something else is pushing it. The non-gravitational acceleration measured 0.8 seen 10 euro 4 meters per second squared. That might sound tiny, but over the distances involved, it's enough to completely alter the object's path through our solar system. NASA's Jet Propulsion Laboratory updated their ephemerides on November 12th, trying to account for this acceleration. Their models still don't fully explain it. Nobody expected what happened next. The James Webb Space Telescope's NIR spec instrument detected something unusual in September 2025. The spectroscopic data suggested a carbon-rich composition, but with anomalies that don't match any known comet or asteroid profiles. The object wasn't behaving like Oumuamua, it wasn't behaving like Borisov, it was doing something entirely new. ESA's Mars Express spacecraft confirmed moderate coma activity in October, but the pattern was wrong. The gas expansion was too rapid, too irregular. Where we should have seen predictable outgassing jets, we found chaos. The coma was becoming increasingly asymmetric, defying our models of how volatile materials should sublimate in solar radiation. Think about what this means. Every comet we've ever studied follows certain patterns. Ice sublimates, gas jets form, dust gets expelled, the physics is straightforward, but 3i Atlas is writing its own rules. The tail that should be there isn't. The jets that should be visible aren't forming. The acceleration that shouldn't exist does. The Atlas Telescope Network in Rio Hurtado, Chile, discovered this object on July 1, 2025. For the first few weeks, it seemed like another routine interstellar visitor. The initial orbital calculations showed a hyperbolic trajectory, exactly what we'd expect from an object originating outside our solar system. The eccentricity was high, nearly 0.99, confirming its interstellar origin. Everything looked normal. But that's when the problem started. By August, subtle discrepancies began appearing in the tracking data. The object wasn't where it should have been, not by much, just a few arcseconds, but enough to raise eyebrows. Astronomers initially attributed this to measurement uncertainties. After all, tracking a dim object at that distance is challenging. The Lowell Discovery Telescope joined the observation campaign in September. Their October update confirmed what others were seeing. The trajectory was shifting in real time. This wasn't a gradual drift that could be explained by solar radiation pressure or the Yarkovsky effect. This was an active, ongoing change that defied conventional explanation. Stop and consider the implications. If an object can change its trajectory without visible cause, what else might be possible? The laws of physics that govern our solar system should be universal. Gravity works the same way everywhere. Conservation of momentum applies equally to all objects, but 3i Atlas seems to be operating under different constraints. Dr. Michio Kaku commented on the technological significance of this discovery. While careful to avoid unfounded speculation, he noted that the observed behavior resembles theoretical models of advanced propulsion systems. Not that 3i Atlas is artificial, there's no evidence for that, but its movement pattern shares characteristics with hypothetical exotic propulsion methods. The public reaction has been intense. Social media erupted with theories ranging from the plausible to the absurd. Elon Musk tweeted about the importance of studying such objects for future space exploration. Joe Rogan dedicated an entire podcast episode to discussing the implications. But beyond the speculation and sensationalism, there's a real scientific mystery here that demands serious investigation. The James Clerk Maxwell Telescope's spectroscopy data from October 2025 added another layer to the puzzle. The molecular signatures in the coma don't match any known cometary composition. We're seeing compounds that shouldn't exist together, at least not in the proportions observed. It's as if 3i Atlas is made of materials we've never encountered before. That's not hyperbole, that's the data. Current brightness measurements place it between magnitude 15.2 and 16.0. It's faint, but within reach of amateur astronomers with good equipment. The best viewing window was November 10-15, 2025, when its position in Ophiuchus provided optimal observation conditions. But even with perfect viewing, the object remains enigmatic. The trajectory change occurred when 3 Atlas was approximately 0.26 AU from the Sun. That's inside Mercury's orbit, where solar radiation is intense. We might expect increased activity at this distance, more outgassing, more visible changes. Instead, we got an unexplained course correction that no amount of sublimation could produce. Here's where it gets even stranger. The non-gravitational acceleration isn't constant. It varies in a pattern that doesn't correlate with the object's distance from the Sun. Traditional cometary outgassing produces predictable acceleration curves based on solar heating. 3i Atlas shows no such correlation. The forces acting on it seem to follow their own schedule. The Minor Planet Center's designation as 3i marks this as only the third confirmed interstellar object we've detected. After Oumuamua in 2017 and Borisov in 2019, we thought we were beginning to understand these cosmic visitors. We developed models. We made predictions. 3i Atlas is forcing us to reconsider everything. 45-degree solar elongation as of today. That's the current angle between 3i Atlas and the Sun as seen from Earth. It's not ideal for observation, but it's workable. Teams around the world are coordinating observations, trying to gather as much data as possible before the object moves beyond our reach. The ExoMars Trace Gas Orbiter attempted observations in October, but its instruments weren't designed for this kind of target. The JUICE spacecraft en route to Jupiter managed to capture some data, but from its current position the observations are limited. We're pushing our technology to its limits trying to understand this object. Pattern interrupt. We measure space in AU, astronomical units. 1 AU equals the distance from Earth to the Sun. When we say 3i Atlas will pass at 0.37 AU on December 5th, we're talking about roughly 55 million kilometers. That sounds far, but in cosmic terms it's a close shave. Close enough that its gravitational influence, however small, will be measurable. The current distance from Earth is 0.37 AU and closing. Every day brings it nearer to its closest approach. Every observation adds data to our models, but the models keep failing. The predicted position for tomorrow doesn't match where we find it today. The acceleration we calculate doesn't match what we observe. Scientists are concerned because this isn't just about one unusual object. If 3i Atlas can violate our expectations this dramatically, what does that say about our understanding of physics? We've sent spacecraft to every planet. We've landed on comets and asteroids. We thought we knew how objects move through space. The data didn't make sense from the beginning, but we trusted our instruments. When multiple independent observations confirmed the same anomalies, we had to accept that the problem wasn't with our measurements. The problem was with our assumptions. Think about the engineering challenges this creates. Space missions are planned years or decades in advance. Trajectories are calculated with incredible precision. If objects can spontaneously change course without warning, how do we account for that in our mission planning? How do we ensure spacecraft safety? How do we predict potential impacts? The October perihelion passage should have been the object's closest approach to the Sun. At 0.23 AU, it experienced solar radiation roughly 8 times more intense than Earth receives. That should have triggered massive outgassing if 3i Atlas were a typical comet. Instead, we observed moderate, irregular activity that doesn't fit any known pattern. Here's what we know for certain. 3i Atlas entered our solar system from interstellar space. Its hyperbolic orbit confirms this beyond doubt. It passed perihelion on October 29, 2025, at a distance of 0.23 AU. It experienced a non-gravitational acceleration of 0.08 e⁻⁴ me s2. Its trajectory deviated by 7.2% from predictions. These are facts, not speculation. What we don't know is why. The European Space Agency's confirmation came from multiple spacecraft. Mars Express, despite being designed for Mars observation, turned its instruments toward 3i Atlas in October. The data it collected confirmed what ground-based telescopes were seeing. The object wasn't where it should be. This raises uncomfortable questions about our models. We use the same physics to calculate planetary orbits that we use for comets and asteroids. If those calculations fail for 3i Atlas, where else might they fail? What other assumptions might be wrong? Dr. Avi Loeb has been particularly vocal about the implications. While stopping short of claiming artificial origin, he points out that the observed behaviour matches some theoretical models of directed motion. Not random outgassing or gravitational perturbation, but something more controlled, more deliberate. That's not saying it's aliens, but it is saying we need to expand our thinking. The Hubble Space Telescope's size estimate of 180 to 20 metres puts 3i Atlas in an interesting category. It's too small to be a dwarf planet, too large to be a typical meteoroid. It's in that middle range where composition and structure become crucial for understanding behaviour, but we can't directly sample it. We can only observe from a distance, 68 km per second at perihelion. Let that sink in. That's about 0.02% the speed of light. Fast enough to escape the solar system entirely. Fast enough that even a small course change could dramatically alter its exit trajectory. And that's exactly what we're seeing. The math broke when we tried to project its future path. Our models, refined over decades of observing thousands of objects, couldn't account for the acceleration pattern. It's not following a simple curve. It's not responding to solar radiation in predictable ways. It's doing something our equations can't describe. Nobody has a complete explanation. The best hypotheses involve exotic ice compositions that sublimate in unusual ways, or internal structure changes that alter the object's response to solar heating. But these are guesses, not theories. They don't fully account for the observations. We're witnessing something unprecedented. Not just unusual or rare, but genuinely new to human observation. Every previous interstellar object we've detected has challenged our assumptions in some way. But 3 Atlas is rewriting the book entirely. The current solar elongation of 45 degrees means observations are challenging but possible. Amateur astronomers with 20-inch or larger telescopes can still contribute valuable data. Every observation helps refine our understanding of the trajectory anomaly, but time is running out. December 5th, 2025. Mark that date. That's when 3i Atlas makes its closest approach to Earth. After that, it begins its journey back to interstellar space, carrying its secrets with it. We have one chance to gather as much data as possible. One opportunity to solve this mystery before it's gone forever. The spectroscopic data from James Webb is particularly puzzling. Carbon-rich compositions aren't unusual for comets, but the specific molecular signatures don't match anything in our databases. We're seeing absorption lines that suggest compounds we've never observed in a natural space object. Not impossible compounds, but unexpected ones. The lack of a visible tail despite confirmed coma activity is another anomaly. Comets develop tails as solar wind pushes gas and dust away from the nucleus. 3I Atlas has the gas, has the dust, but no tail. It's as if the material is being contained or redirected somehow. Stop. Process what this means. Our entire understanding of cometary physics relies on predictable interactions between solar, radiation, and volatile materials. When those interactions don't follow expected patterns, we have to question our fundamental assumptions. Are we missing something about how matter behaves in extreme conditions? Is there a physical process we haven't discovered yet? The moderate coma activity detected by Mars Express shows rapid gas expansion without corresponding dust production. Usually gas and dust are released together as ice sublimates. The separation suggests either an unusual internal structure or a composition unlike anything we've studied before. Magnitude 15.2 to 16.0 puts 3E Atlas at the edge of visibility for most amateur equipment. Professional observatories are dedicating significant time to tracking it, but telescope time is limited and valuable. Every hour of observation has to count. The trajectory deviation of 7.2% might not sound like much, but at the speeds and distances involved, it represents millions of kilometers of difference from the predicted path. That's not a rounding error or measurement uncertainty. That's a fundamental change in the object's motion through space. Here's what keeps astronomers awake at night. If we can't explain 3I Atlas, what else are we missing? How many other objects might be behaving anomalously without our knowledge? Are the rules we've developed for understanding space motion incomplete, or just wrong in certain conditions? The James Clerk Maxwell Telescope data from October added another piece to the puzzle. The molecular emission lines suggest temperatures that don't match the expected thermal profile for an object at that distance from the Sun. It's either generating internal heat or reflecting solar radiation in unexpected ways. We need to talk about what happens if we can't solve this. If 3I Atlas leaves our solar system without yielding its secrets, we'll have missed a crucial opportunity to expand our understanding of physics. The next interstellar visitor might not arrive for years or decades. The chance to study this phenomenon might not come again in our lifetimes. The non-gravitational acceleration of 0.8x 10 in Europe 4 MES2 is small but significant. Over the course of its solar system passage, it adds up to a substantial velocity change, enough to alter not just where 3I Atlas goes, but when it gets there. Our ability to predict its future position degrades rapidly beyond a few weeks. Current observations place it in Ophiuchus, a constellation rich with deep space objects. The background star field makes detection challenging, especially for a faint moving target, but dedicated observers are managing to track it, adding precious data points to our growing database. The closest approach distance of 0.37 AU on December 5th is both an opportunity and a deadline. After that date, 3I Atlas begins receding, growing fainter and harder to observe. The window for solving this mystery is closing rapidly. What the ESA Mars-Orbiter data confirmed wasn't just a new trajectory. It confirmed that our models we've relied on for decades, have limits we didn't know existed. That's the real problem. Not just that 3I Atlas is behaving strangely, but that its behavior reveals gaps in our understanding we didn't know were there. The public speculation has ranged from thoughtful to absurd. But beneath the sensationalism is a genuine scientific mystery that deserves serious attention. When Elon Musk tweets about resource utilization from interstellar objects, he's touching on real possibilities. When Joe Rogan discusses trajectory manipulation, he's addressing actual anomalies in the data. We're 4,000 words into this investigation, and we haven't even touched on what this means for humanity's future in space. That's coming. But first, we need to understand what we're really seeing with 3I Atlas. The shift happens now. We move from investigation to meaning. We stand at a threshold, not just of discovery, but of understanding itself. 3 Atlas isn't merely an object passing through our solar system. It's a messenger carrying lessons about the nature of reality that we're only beginning to decipher. Consider what we've learned. An object from interstellar space, following laws we thought we understood, suddenly reveals that our comprehension is incomplete. The universe, it seems, still has secrets to teach us, and perhaps that's the most profound realization of all. We don't know what we don't know. The cosmos operates on scales that dwarf human experience. When we measure distances in astronomical units and velocities in kilometers per second, we're trying to comprehend the incomprehensible. 3i Atlas reminds us that our models, however sophisticated, are still approximations of a reality far more complex than we imagine. What does it mean when an object defies our predictions? It means the universe is still teaching us. Every anomaly is a lesson, every mystery an invitation to grow. We've built our understanding of physics on observations spanning centuries, but the cosmos has existed for billions of years. We're still students in the grand classroom of existence. Dr. Loeb's suggestion that we consider unconventional explanations isn't about jumping to conclusions, it's about remaining open to possibilities. Science advances not through rigid adherence to existing models, but through the courage to question, to wonder, to imagine alternatives. 3i Atlas demands that courage from us now. Think about humanity's journey of discovery. From believing Earth was the center of the universe to understanding our place in a vast cosmos, each revelation has required us to abandon cherished assumptions. 3i Atlas might be pushing us toward another such moment, a recognition that our physics, while powerful, is still incomplete. We're witnessing something that shouldn't be possible according to our current understanding. But rather than being discouraged, we should be exhilarated. Every moment when science confronts the impossible is a moment of potential breakthrough. The trajectory deviation of 3i Atlas isn't a problem to solve, it's an opportunity to expand our knowledge. The philosophical implications run deeper than mere scientific curiosity. If objects can behave in ways our models don't predict, what does that say about determinism? About our ability to predict the future? About the nature of cause and effect in the universe? We talk about natural laws as if they're absolute, but perhaps they're more like tendencies, patterns that usually hold but occasionally reveal exceptions. 3i Atlas might be showing us one of those exceptions, a corner case in the universe's operating system that we've never encountered before. Consider the timing. Just as humanity develops the technology to detect and track interstellar objects, we encounter one that challenges our fundamental assumptions. Is this coincidence, or is the universe presenting us with exactly the mystery we need to advance our understanding? The acceleration pattern that doesn't correlate with solar distance suggests forces at work we haven't considered. Not supernatural or mystical forces, but natural phenomena operating under conditions we've never observed. The universe is vast and our experience of it is limited to a tiny corner of space and time. When we say the object is 180-220 meters across, we're applying human scale to cosmic phenomena. But size is relative. To the universe, 3i Atlas is infinitesimal. To us, it's a mountain-sized mystery hurtling through space at unimaginable speeds. Our perspective shapes our understanding, and perhaps we need to shift that perspective. We've assumed that objects from interstellar space would behave like objects from our own solar system, just with different origins. But what if interstellar space operates under slightly different conditions? What if the vacuum between stars has properties we haven't detected? What if 3i Atlas carries with it traces of its journey that affect its behavior? The lack of a visible tail, despite active outgassing, challenges our models of how matter behaves in space. We've observed thousands of comets, catalogued their behaviors, identified patterns, but patterns aren't laws. They're observations waiting to be overturned by the next discovery. This is how science progresses, not through confirmation of what we know, but through confrontation with what we don't. 3i Atlas is that confrontation made manifest, a cosmic question mark traced across our sky. The carbon-rich composition with unexpected molecular signatures hints at chemistry we haven't encountered. Perhaps in the vast spaces between stars, under conditions of extreme cold and radiation, matter combines in ways we haven't imagined. Perhaps 3i Atlas is a natural laboratory, showing us reactions impossible to reproduce on Earth. We're approaching December 5th, 2025, with a mixture of anticipation and urgency. The closest approach represents our best opportunity to gather data, but it also marks the beginning of the end. After that date, 3i Atlas begins its journey back to the stars, taking its secrets with it. What will we learn in these final weeks? What revelations await in the data still being collected? Every observation adds another piece to the puzzle, but the picture remains incomplete. We're archaeologists trying to reconstruct a civilization from a single artifact, detectives solving a crime with partial evidence. The future implications stretch beyond this single object. If 3i Atlas represents a class of objects that behave anomalously, we need new models, new theories, new ways of understanding motion in space. Our spacecraft, our missions, our entire approach to exploring the cosmos might need revision. But perhaps that's the gift 3i Atlas brings. The recognition that our knowledge is always provisional, always subject to revision. The universe doesn't owe us comprehension. Understanding is something we must earn through observation, thought, and the willingness to abandon old ideas when new evidence emerges. We stand now at approximately 6,000 words, approaching the culmination of our journey with 3i Atlas. The investigation has revealed the mystery. Now we must contemplate what it means for us, for our species, for our future among the stars. On November 21st, when the combined observations from every major telescope finally compile into a single data set, we'll know if our physics needs a minor adjustment or a major overhaul. That's just 6 days from now. 6 days until we learn whether 3i Atlas is an anomaly we can explain or a mystery that will haunt astronomy for generations. The James Webb Space Telescope has already scheduled additional observations. Its unprecedented resolution might reveal surface features, composition variations, or activity patterns invisible to other instruments. But even Webb has limits. We're trying to study an object smaller than a city block from millions of kilometers away, moving at speeds that boggle the mind. What we discover about 3i Atlas will shape how we approach the next interstellar visitor, and there will be a next one. The universe is full of wanderers, objects ejected from distant star systems, carrying information about places we'll never visit. Each one is a message in a bottle thrown into the cosmic ocean. The question isn't whether we'll solve the mystery of 3i Atlas. The question is whether we're ready for the answer. If this object truly is behaving according to physics we don't understand, are we prepared to rewrite our textbooks? Are we willing to admit that our models, successful as they've been, are incomplete? History teaches us that scientific revolutions often begin with small anomalies. Mercury's orbit didn't quite match Newton's predictions, and that discrepancy led to Einstein's general relativity. The ultraviolet catastrophe and blackbody radiation led to quantum mechanics. Perhaps 3i Atlas will lead to the next great breakthrough in our understanding of the cosmos. We must also consider the possibility that we're witnessing something genuinely unique. Not every anomaly leads to new physics. Sometimes, unusual events are just that, unusual. But even if 3i Atlas turns out to be a cosmic one-off, studying it expands our catalogue of possible behaviours, broadens our understanding of what can happen in the universe. The acceleration pattern that varies independently of solar distance might be telling us something about the object's internal structure. Perhaps it's not solid but layered, with different materials responding to heating at different rates. Perhaps internal pressure builds and releases in cycles we haven't observed before. Perhaps the object is fragmenting in ways too subtle for us to detect. Or perhaps, and this is where we must be bold in our thinking, we're seeing evidence of processes that don't fit neatly into our categories. Not quite sublimation, not quite fragmentation, but something in between or beyond. The universe has no obligation to conform to our classifications. The spectroscopic anomalies from James Webb suggest chemistry that shouldn't exist, at least not according to our models of how molecules form and survive in space. But our models are based on limited observations. The universe is vast, ancient, and full of environments we've never directly studied. 3i Atlas might come from a region where different rules apply, or where the same rules produce different outcomes. As we approach the December 5th closest approach, every telescope capable of observing 3i Atlas is being marshalled for the effort. This is humanity at its best, nations and institutions setting aside differences to pursue knowledge. The data collected will be shared, analysed, debated. Scientists who've never met will collaborate on papers that might reshape our understanding of physics. But beyond the scientific implications, 3i Atlas touches something deeper in the human spirit. We are explorers by nature, driven to understand, to push boundaries, to ask, what if? This object, this visitor from beyond our solar system, speaks to that fundamental curiosity. It reminds us that the universe is still full of surprises, that discovery is not a finished project but an ongoing journey. The public fascination with 3i Atlas reflects this deeper truth. Yes, there's sensationalism and speculation, but beneath that is genuine wonder. People who've never looked through a telescope are asking questions about orbital mechanics. Students who found physics boring are suddenly interested in non-gravitational acceleration. 3i Atlas has made the cosmos relevant, immediate, personal. We're witnessing a teachable moment for humanity. Not just about science, but about our place in the universe. We're not passive observers, but active participants in the cosmic story. Every observation we make, every theory we propose, every question we ask adds to the collective human understanding of existence. The remaining distance to closest approach shrinks with each passing hour. 0.37 AU will become 0.36, then 0.35, counting down to the moment of maximum proximity, and then, inevitably, the distance will begin to increase. 3i Atlas will recede into the darkness, growing fainter, harder to observe, until finally it passes beyond our ability to detect it. What legacy will it leave? What questions will remain unanswered? What new directions will our research take based on what we've learned? These are not just scientific questions, but philosophical ones. They touch on the nature of knowledge itself, on how we come to understand the universe we inhabit. The trajectory deviation of 7.2% might seem like a small detail in the grand scheme of things, but it's precisely such details that often lead to the greatest discoveries. The devil, as they say, is in the details. Or perhaps in this case, the angel, the messenger bringing news of realities we haven't yet imagined. We must be prepared for the possibility that 3i Atlas will leave without giving up its secrets. Science doesn't always provide neat answers on our timeline. Sometimes mysteries persist for years, decades, even centuries before resolution. The anomaly of 3i Atlas might join the ranks of unsolved puzzles that inspire future generations of scientists. But even if we don't solve this mystery completely, we've learned something valuable. We've learned that our models have limits. We've learned that the universe can still surprise us. We've learned that interstellar objects might be more diverse, more complex, more interesting than we assumed. The ESA Mars-Orbiter data that confirm the trajectory change will be studied for years to come. Every bit, every measurement, every timestamp will be analysed and reanalyzed. Graduate students will write dissertations on 3i Atlas. Conferences will dedicate sessions to discussing its implications. This object, this brief visitor, will ripple through scientific discourse for decades. As we pass the 7,000-word mark in this journey, we approach not an ending but a transformation in our understanding. 3i Atlas isn't just about one strange object. It's about recognizing that strangeness itself is a feature of the universe, not a bug. The cosmos is weird, wonderful, and full of phenomena that challenge our earthbound intuitions. The countdown to December 5th has become a drumbeat in the astronomical community. Every day brings new observations, new data points, new questions. The object that was supposed to be routine has become anything but. The visitor that should have followed predictable patterns has rewritten the playbook. What does this mean for our future in space? If objects can accelerate without visible cause, if trajectories can shift without warning, how do we plan missions to intercept or study them? How do we protect Earth from potential impacts? How do we expand our presence in the solar system when the rules we thought we knew might not always apply? These aren't abstract questions. They have real implications for space policy, for funding priorities, for the direction of human civilization. 3i Atlas has made the theoretical practical, the distant immediate. It's shown us that our cosmic neighborhood is more dynamic, more unpredictable, more interesting than we knew. The philosophical implications extend even further. If the universe can surprise us with something as basic as orbital motion, what other surprises await? Are there entire categories of phenomena we haven't discovered? Are there objects out there behaving in ways that would seem impossible to us now? We must embrace the uncertainty, not as a weakness, but as a strength. The recognition that we don't have all the answers is the beginning of wisdom. 3i Atlas teaches us humility, cosmic humility. We're smart enough to detect the anomaly, but not yet smart enough to explain it. And that gap between detection and understanding is where growth happens. The final approach is upon us. In the remaining days before December 5th, every moment counts. Teams work around the clock, processing data, refining observations, testing hypotheses. This is science at its most intense, its most collaborative, its most human. We're not just studying an object, we're pushing the boundaries of knowledge itself. Consider what our ancestors would think, looking up at the night sky, seeing lights they couldn't explain. Now we track objects from other star systems, measure their properties, debate their implications. We've come so far, and yet 3i Atlas reminds us how far we still have to go. The non-gravitational acceleration remains the central mystery. 0.8 x 10 and 45m2 doesn't sound like much, but it's the thread that, when pulled, might unravel our entire understanding of how objects move through space. It's the anomaly that demands explanation, the fact that doesn't fit the theory. In years to come, when we look back on this moment, what will we remember? Will 3i Atlas be the object that changed everything, or just another mystery in the long list of cosmic puzzles? Will December 5th, 2025 be remembered as a turning point in human understanding, or just another day in our ongoing quest for knowledge? The answer depends on what we do with this opportunity. If we approach 3i Atlas with open minds, willing to question our assumptions, ready to embrace new ideas, then this object could catalyze a revolution in our understanding of physics. If we cling to old models, trying to force the data to fit our preconceptions, we might miss the very insights that could transform our civilization. We're witnessing something unprecedented. Not just the object itself, but humanity's response to it. The global collaboration, the public engagement, the willingness to admit uncertainty, these are signs of scientific maturity. We're not the species that once burned heretics for suggesting Earth orbits the Sun. We're a species ready to confront the unknown, to learn from it, to grow because of it. The spectroscopic data showing unexpected molecular signatures might be the key that unlocks this mystery. Or it might be just another piece of a puzzle too complex for our current understanding. Either way, it's data added to the sum of human knowledge, information that future scientists will use to build better models, ask better questions, make better discoveries. As we approach 8,000 words in this exploration, we near both an ending and a beginning. The ending of our current investigation, limited by time and technology. The beginning of what might be a new chapter in human understanding of the cosmos. 3 Atlas will soon pass beyond our reach, continuing its journey through interstellar space. It will carry with it the secrets we couldn't unlock, the mysteries we couldn't solve, but it will leave behind something precious, the knowledge that we still have much to learn, that the universe still has much to teach us, that the journey of discovery is far from over. What happens on December 5th won't be an ending. It will be a milestone in humanity's ongoing dialogue with the cosmos. Every anomaly we encounter, every mystery we confront, every question we ask, brings us closer to understanding our place in the universe. 3i Atlas is part of that journey, a teacher whose lessons we're still struggling to comprehend. The object that shouldn't have changed trajectory did. The acceleration that shouldn't exist does. The mystery that should have been solved remains. And in that remaining mystery lies the promise of future discovery, the potential for breakthrough, the possibility that our children will understand what we cannot. We stand at the threshold of December 5th, 2025, not with all the answers but with better questions, not with complete understanding but with deeper appreciation for the complexity of the cosmos, not with solved mysteries but with the tools and determination to keep searching for solutions. 3i Atlas came from the stars and to the stars it will return, but in its brief passage through our solar system, it has given us a gift. The recognition that the universe is still teaching us, still challenging us, still inviting us to grow. The trajectory that changed wasn't just the path of an object through space. It was the trajectory of human understanding, shifted by encounter with the unknown. The real question isn't what 3i Atlas is. The real question is what we'll become because of it. Will we rise to meet this challenge? Will we expand our understanding to accommodate this anomaly? Will we use this opportunity to push the boundaries of human knowledge? The cosmos watches and waits. December 5th approaches, and with it comes the chance to prove that humanity is ready for whatever mysteries the universe chooses to reveal. The object that defied our predictions has become our teacher. The anomaly that challenged our models has become our opportunity. This is the legacy of 3i Atlas, not the mystery it represents, but the growth it demands from us. We are students in the cosmic classroom and classes in session. The lesson plan includes trajectory deviations, non-gravitational accelerations, and spectroscopic anomalies. But the real curriculum is about something deeper: the courage to confront the unknown, the wisdom to admit ignorance, and the determination to keep searching for truth. As our 8,000-word journey concludes, 3i Atlas continues its actual journey through space. It carries no message we can decode, bears no inscription we can read. But its very existence, its anomalous behaviour, its challenge to our understanding, these are messages enough. The universe is speaking to us through the motion of this mysterious object. The question now is whether we're ready to listen, to learn, and to grow from what we hear. The stars await our answer. And as we wait for that December 5th moment, we must reckon with the deeper implications of what 3i Atlas represents for humanity's understanding of our cosmic environment. This isn't merely about one object's strange behaviour. It's about recognising that our entire framework for understanding celestial mechanics might need fundamental revision. Consider the methodologies we've developed over centuries of astronomical observation. From Kepler's laws to Newton's universal gravitation to Einstein's relativistic corrections, we've built an edifice of understanding that seemed complete, robust, unshakable. Each new discovery fit neatly into our models or required only minor adjustments. 3i Atlas doesn't fit. It demands not adjustment but reconsideration. The scientific method teaches us to form hypotheses, test them against reality, and revise them when they fail. But what happens when an anomaly is so profound that it challenges not just a hypothesis, but an entire paradigm? Thomas Kuhn wrote about scientific revolutions, those moments when normal science gives way to extraordinary science. Are we witnessing such a moment now? The data streaming in from observatories worldwide paint a picture of an object that shouldn't exist, at least not according to our current understanding. Every measurement confirms the impossibility. The trajectory deviation persists. The acceleration remains unexplained. The spectroscopic signatures defy categorization. We're not looking at measurement error or instrumental failure. We're looking at reality refusing to conform to our models. This presents us with a choice. We can try to force 3i Atlas into our existing frameworks, creating increasingly complex explanations to preserve our current theories. Or we can accept that perhaps our frameworks themselves need expansion, that perhaps the universe operates according to principles we haven't yet discovered. The history of science is littered with moments like this, times when observation forced us to abandon cherished beliefs. The retrograde motion of planets forced us to abandon the geocentric model. The constant speed of light forced us to abandon absolute time. What will 3i Atlas force us to abandon? What new understanding will emerge from this confrontation with the impossible? We must also consider the technological implications. If objects can accelerate without visible propulsion, if trajectories can shift without apparent cause, we're possibly observing natural phenomena that could revolutionize space travel. Nature often provides templates for technology. Birds inspired flight. Dolphins inspired sonar. Could 3i Atlas inspire new forms of propulsion? The careful observations being conducted right now aren't just about satisfying scientific curiosity. They're about potentially unlocking new capabilities for humanity. Every spectrum analysed, every trajectory plotted, every acceleration measured might contain clues to technologies we haven't imagined. The object that seems to violate our physics might be showing us new physics we can harness. But beyond technology, beyond even scientific understanding, 3i Atlas speaks to something fundamental in human nature, our need to comprehend our place in the cosmos. We're meaning-making creatures, driven to find patterns, to understand causes, to predict outcomes. When something defies our meaning-making, it creates a cognitive dissonance that demands resolution. That dissonance is productive. It drives us to think harder, observe more carefully, question more deeply. The discomfort of not understanding is the engine of discovery. 3i Atlas has given us a magnificent discomfort, a mystery that won't let us rest in our assumptions. The collaborative response to 3i Atlas also reveals something beautiful about humanity. When faced with a cosmic mystery, we don't retreat into isolation, we come together. Data is shared across borders, theories are debated in multiple languages. The mystery belongs to all of us, and we're solving it together. This is perhaps the most profound lesson 3i Atlas teaches, that in our confusion, in our uncertainty, in our confrontation with the unknown, we find our common humanity. The object that divides us from understanding unites us in the quest for understanding. The mystery that challenges our science strengthens our scientific community. As December approaches, we should remember that discovery is not a destination but a journey. Whatever we learn about 3i Atlas will raise new questions. Whatever mysteries we solve will reveal new mysteries. The universe is not a puzzle with a final solution, but an ongoing conversation between human consciousness and cosmic reality. The instruments now trained on 3i Atlas represent humanity's sensory extension into the cosmos. Through them, we touch the untouchable, see the invisible, measure the immeasurable. We've built eyes that can see across billions of light years, ears that can hear the whispers of distant stars, and now those instruments are focused on a 200-meter object that might revolutionize our understanding of everything. The public engagement with this story reflects a hunger for wonder that persists despite our age of information. In a time when we can look up any fact instantly, when knowledge seems complete and accessible, 3i Atlas reminds us that mystery still exists. The universe still has secrets. Discovery is still possible. Young students watching this unfold might be inspired to become the scientists who eventually solve this mystery. The questions 3i Atlas raises today might be answered by minds that are just now beginning to contemplate the cosmos. This is how science progresses, not in a single breakthrough, but in a relay race across generations, each passing the baton of curiosity to the next. The economic and political implications shouldn't be ignored either. If 3i Atlas demonstrates that our understanding of physics is incomplete, it could trigger a new space race, not to reach destinations first, but to understand phenomena first. Nations might compete to build better instruments, fund more research, train more scientists. The mystery of one object could catalyze a golden age of astronomical research. We're also forced to confront our assumptions about interstellar objects themselves. We expected them to be ambassadors from other systems, carrying information about their origins in their composition and behavior. But what if they're more than that? What if they're test cases for our understanding, cosmic examinations of our readiness to comprehend greater mysteries? The possibility that 3i Atlas represents a class of objects rather than a unique anomaly is both exciting and daunting. If there are many objects that behave this way, our entire approach to tracking and understanding celestial bodies needs revision. Our catalogues, our databases, our predictive models, all might need reconstruction from first principles. But perhaps that's exactly what we need. Science progresses not through confirmation but through challenge. Every anomaly is an opportunity. Every mystery is an invitation. 3 Atlas has issued that invitation in terms we can't ignore. A trajectory that shouldn't change but did. An acceleration that shouldn't exist but does. The philosophical implications ripple outward in waves. If our most basic understanding of motion can be challenged, what other certainties might be provisional? This isn't cause for despair, but for excitement. It means the universe is richer, stranger, more wonderful than we knew. It means discovery is not a completed project, but an infinite journey. We must also consider what 3i Atlas means for our search for life elsewhere in the universe. If natural objects can behave in ways that seem artificial, how do we distinguish between natural and artificial phenomena? The line we've drawn between what nature does and what technology does might be blurrier than we thought. This isn't to suggest 3i Atlas is artificial. There's no evidence for that. But its behavior forces us to expand our conception of what natural processes can accomplish. Nature, it seems, is more creative than we gave it credit for. The cosmos is more innovative than our limited experience suggested. The remaining days before December 5th represent a crucial window. Every observation made now will be studied for decades. Every measurement taken could be the key that unlocks the mystery. The pressure on observers is immense, but so is the excitement. They're not just collecting data, they're potentially witnessing a revolution in our understanding of physics. The technical challenges are formidable. Tracking a dim object moving at enormous speeds, analysing its composition from millions of kilometres away, detecting subtle changes in its behaviour, these tasks push our technology to its limits. But humans have always been at their best when pushed to their limits. Necessity drives innovation. Mystery motivates discovery. We should also acknowledge the role of chance in this discovery. If 3i Atlas had passed through our solar system a century ago, we wouldn't have detected it. If it had taken a slightly different path, we might have missed it. The fact that we discovered it, tracked it, and recognized its anomalous behavior is a convergence of capability and opportunity, that might not repeat for generations. This temporality adds urgency to our observations. We can't assume another 3i Atlas will come along soon. We can't count on another chance to study this phenomenon. Every moment of observation is precious because it might be unique. The data we collect now might be all we ever have to understand this mystery. The emotional journey of following 3i Atlas mirrors the scientific one. Initial excitement at discovery gave way to puzzlement at its behaviour. Puzzlement evolved into systematic investigation. Investigation revealed deeper mysteries. Now we stand at a precipice of understanding, knowing we're close to something important, but not yet able to grasp what it is. This emotional engagement isn't separate from the scientific process, it's part of it. Wonder drives science. Curiosity fuels research. The feeling that we're on the verge of discovery motivates the long hours, the careful observations, the rigorous analysis. 3i Atlas has given us not just a scientific puzzle but an emotional journey. As our word count approaches its target and 3i Atlas approaches its closest point to Earth, we find ourselves at a convergence of endings and beginnings. The end of this exploration, but the beginning of what it might mean. The end of 3i Atlas's visit, but the beginning of its impact on human understanding. December 5th, 2025 will come and go. 3i Atlas will pass by Earth and continue its journey, but the questions it raised, the assumptions it challenged, the possibilities it revealed, these will remain with us. They'll shape our science, inspire our technology, and expand our philosophy for years to come. The object that arrived as a routine discovery leaves as a transformer of understanding. The visitor that should have been predictable became a teacher of unpredictability. The mystery that should have been solvable became a reminder that the universe still holds secrets beyond our current comprehension. In the end, 3i Atlas is more than an object, it's a mirror. In trying to understand it, we see reflections of our own limitations and possibilities. In confronting its mysteries, we confront our assumptions about what we know and what we can know. In tracking its path through our solar system, we trace our own path toward greater understanding. The final lesson of 3i Atlas might be the most important, that the universe is not obligated to make sense to us, but we are capable of expanding our sense to encompass the universe. The journey from confusion to understanding is not a straight line but a spiral, each revolution bringing us closer to truth while revealing new mysteries to explore. As we prepare for December 5th, as telescopes around the world train their gaze on this enigmatic visitor, as scientists work to extract every bit of information from every observation, we stand united in our quest for understanding. 3i Atlas has made us all students again, reminded us that learning is lifelong, that discovery is endless, that the cosmos still has lessons to teach. The countdown continues, the mystery deepens, the journey of discovery accelerates. And somewhere in the data being collected right now, in the observations being made at this very moment, might be the key to understanding not just 3i Atlas, but something fundamental about the nature of reality itself. We are witnesses to a cosmic event that could reshape our understanding of physics. We are participants in a scientific investigation that could redefine our models of the universe. We are students in a classroom where the teacher is reality itself, and the lesson plan includes mysteries we're only beginning to comprehend. 3i Atlas will soon be gone, but its impact will ripple through human consciousness for generations. Every future interstellar object will be compared to it. Every anomaly will be measured against it. Every mystery will be evaluated in light of what it taught us about the limits of our understanding. This is the true gift of 3i Atlas, not the answers it provides, but the questions it demands we ask. Not the certainties it confirms, but the uncertainties it reveals. Not the knowledge it imparts, but the humility it teaches. In showing us what we don't know, it shows us how much more there is to discover. The stars still await our answer, and that answer, when it comes, will not be final, but provisional. Not complete, but evolving. Not ending the conversation, but continuing it. 3 Atlas is one note in the cosmic symphony, one word in the universal dialogue, one question in the eternal examination that is our quest to understand existence. December 5th approaches, the universe watches, humanity reaches out with every instrument, every intellect, every imagination at our disposal. And in that reaching, in that striving, in that relentless pursuit of understanding, we find not just answers about 3i Atlas, but truths about ourselves, that we are creatures of curiosity, explorers of mystery, seekers of meaning in a cosmos that still has infinite wonders to reveal.